Welcome back, Life Science class. Mrs. Erickson here. Today I'm going to be covering the section 10.2 plant responses, but I'm only going to cover the first half. So today I'm just going to focus primarily on how plants respond to a number of environmental factors. We'll talk a little bit about phototropism, thigmotropism, gravitropism, photoperiodism, so basically environmental. And then tomorrow's lecture we'll talk about chemical stimuli, how do plants respond to a chemical stimuli. So first off, let's just break down what the word stimuli means. It's basically any change in an organism's environment that causes a response. You know, if you guys were in class, I usually have my little foam ball and I chuck it at someone in the front row, and we watch their response. A lot of times they flinch or close their eyes, expecting some type of impact. So that's a stimuli. Stimuli, they can be slow, like a plant moving towards the light. You don't see it right away, but maybe over the period of the day you do, or think about a sunflower field. Or they can be very quick, like the Venus flytrap. So I'm going to show you a short little 2-minute clip. I'm not sure if I've ever shown you this before, but it's from the BBC. It's pretty good.
The Venus flytrap. Like the sundew, it makes itself very attractive, oozing nectar across the brim of each leaf. But any visiting insect had better watch out for these 6 tiny hairs. This fly has to tread carefully. If it strikes one hair, it can carry on feeding, but a timer has been set. A second strike in less than 20 seconds, and the fly is doomed. An electrical impulse is triggered, and the leaf snaps shut in just a fraction of a second. The tips lock together like prison bars. If the fly is very big or very small, it may just manage to escape. But most are trapped and die. Ten days later, the trap reopens. All that remains is a husk. The plant has finished its meal and resets itself for its next victim.
Okay, so if YouTube trims that out, you can just Google Venus flytraps on YouTube and watch some awesome videos. But I really think the BBC does a great job on Venus flytraps. Okay, moving on to environmental stimuli. What are the environmental stimuli? Well, we're going to talk about 3 big ones. So all of these words have the word tropism in it. And tropism means that it either grows toward or away from that stimulus. So phototropism means that it will grow towards the light. Thigmotropism means its stimuli is touch. So a pea plant and its little tendrils, they tend to climb up objects, and so that response is touch. And then we also have gravitropism, basically gravity, the presence of gravity. So you can actually do this experiment where you grow a plant upright. So if you flip this pot upright, and then you flip it off to the side, and it will still realize which way is up. Okay, so a positive tropism means that it grows toward the object, and a negative tropism means that it grows away, in this case with gravity. Oh, sorry, I guess I have a short video here. Again, if YouTube trims it out, because YouTube does do that, you just type in this down here, plants, tropism, and hormones. So.
The unfurling of a flower as a day breaks, or the snap of a Venus flytrap shutting. Occasionally, plants can respond very quickly to a stimulus. But most responses in plants are far too slow to see in real time. These responses are controlled by growth. Growth responses are constantly at work, directing plants towards or away from a stimulus to seek out the best conditions. They're called tropisms. The most crucial plant tropisms are to light, gravity, and water. Responses to light are called phototropism. Responses to gravity are geotropism, and responses to water are hydrotropism. Growth responses are either positive or negative, towards or against the stimulus. For example, when this seed germinates, the shoot will always grow towards light and upwards against gravity. Whilst the roots always grow down into the soil and towards water. But how do plants control these growth responses? The answer is a plant hormone made at the tips of stems and roots, auxin. The amount of auxin can be affected by external conditions, and it encourages growth. For instance, because light falls unevenly on this stem, more auxin accumulates on the shaded side, causing it to grow faster. The result is a stem that bends towards the light. Knowing the effects of plant hormones means we can use them for our own benefit. Auxins are used in rooting powder to stimulate root growth on plant cuttings and increase fruit yields. For all plants, tropisms provide a critical response system, allowing them to seek out the best conditions for survival.
Okay, so I know they use some different terminology for tropisms, but they're pretty much identical or the same. And then it also talked about a chemical response that plants use, basically the chemical stimuli, which we'll discuss in tomorrow's lecture. Okay. One more that I kind of want to bring up is the flowering response due to darkness. We call this photoperiodism. So plants respond to the number of hours of darkness in their environment. And so maybe you have bought flowers from a store, and you're going to plant them in your garden, around Memorial Day, and you might be reading the little paper insert information about the plant that you purchased, morning glories, or I don't know. But maybe you see terms like long day, short day, or day neutral plants. And so I'm just going to talk about briefly these three types of plants. So long day plants means that they respond to less than 10 to 12 hours of dark. And these plants tend to flower in the summer because our dark period of darkness is shorter. I mean, our days can be 16 to 18 hours long, and then you get 6 to 8 hours of dark or less. So it's less than 10 to 12 hours of darkness. So these are flowers that kind of bloom in the summer. Short day plants means that you have a lot of hours of darkness. More than half your day is in darkness. And so I like to think of, especially here in Minnesota, winter. Okay, flowers that bloom during winter. And poinsettias are a great example of that. That's why you always see them around Christmas time, maybe at like your church. Day neutral means that they are not affected by hours of darkness. Okay, so it does not affect them at all. And a great example is roses. Okay, this is not your assignment. Your assignment is actually a 10.2 worksheet. You could start on one side. The other side, I think, is mostly about chemical responses. Maybe the bottom half is environmental. Don't quote me on that. I don't remember offhand. But tomorrow I'm going to wrap up the plant responses, aka chemical stimuli, tomorrow. Make sure you guys answer your exit card.